Chapter 11, Section 5 is about dividing polynomials. So we're going to focus a little bit extra on dividing. We've already spent a lot of time with multiplying polynomials and multiplying monomials way back in Chapter 7. And so today I want to go over how we can divide polynomials, and there's a couple of different ways or cases that we're going to talk about. The first case is if you're taking a polynomial divided by a monomial. So remember, a polynomial would be something that has several terms, like x squared plus x plus 5 would be an example of a polynomial, where a monomial is a singular term, like 3x. Or it could be x squared, or it could be x squared y, z, something like that. When you're trying to divide a big polynomial by a small monomial, a singular term like that, what you need to do is think about breaking it into like smaller division problems, and you're going to divide each piece on the top, so each piece from that polynomial, you're going to divide separately by that monomial, however many times that you need to do that. So for example, on this first one here, I have 10x to the fourth plus 15x to the third plus 5x, and that's all over a 5x squared. So what you can actually do here to think about how would you divide this is split this into 3 separate division problems. And I say 3 because there's 3 separate terms on the top of that fraction. So you're going to take 10x to the fourth and divide that by 5x squared. And then we have a plus sign there in the middle of those terms. Then take 15x to the third and divide that by 5x squared. And then we have plus again, and then 5x divided by 5x squared. Then what you can do is look to see, is there anything that we can simplify from each of these separate problems to get to our final answer. So for this first part of the fraction, that 10 over 5, you can take 10 divided by 5 and get 2. And then if on top you have x to the fourth and on the bottom you have x squared, remember you can subtract your exponent, so 4 minus 2 would be squared, so that first term becomes a 2x squared. Moving on to the middle term, 15 divided by 5 would be a 3. And then again, if I subtract my exponents on these x's, 3 minus 2 would be 1, so that would just be an x. Now the last one, you can divide 5 by 5, which would be a 1. But be careful here, because if you subtract 1 minus 2, that's going to be a negative 1. So what you're going to want to do for this one is make sure that you bring that x, because it would technically have a negative exponent. Like this would become 1 x to the negative 1. You're going to need to think about the fraction here and move this to the bottom of the fraction. So it would be 1 over your x to the first power, or just x. And so this would be your answer after you divide it. So I want you guys to try to do this one. So I'm going to start by splitting this apart into separate problems, separate division problems. Whoops. So for this first one, everything's the same. So it's the same quantity being divided by itself, so that becomes a 1. Minus 8 divided by 4 would be 2. Subtract my exponents. I'm left with x squared, so minus 2x squared. And then plus 12 divided by 4 would be 3. 8 minus 4 would be 4, so 3x to the fourth power. So that's case number 1, where we take this big polynomial and we're dividing by a monomial term. Now the second case I want to go over with you guys is when you're trying to divide a polynomial by a binomial. So again, a polynomial is going to be like those bigger expressions that have lots of letters, lots of numbers. So it could be, starting even as big as like x to the fifth, x to the sixth, and kind of working its way down. Now a binomial, remember, binomial means that it has 2 terms. So a binomial would be something like x plus 3, where you have 2 separate terms and they're separated by that plus or minus sign. Now in order to do this case, we have to use something that you guys have learned a long time ago, long division. And to get us started on this, before we jump into dividing polynomials using long division, I want to review with you guys how you would do long division if you just had numbers. So back in elementary school, when you guys were learning how to divide for the first time, this is when you would have seen this brought up when you're doing this long division style to try to figure out what it would be. And this is when the first idea of like remainders and how numbers can't go into some numbers evenly would have come up for you, and you would have learned about how to write a remainder and what that means as far as the fractional portion of a number. So for this problem, I've got this 1,334, and I'm trying to divide that by 21. So I'm going to set it up in my division problem here. Now, if you remember, you start by trying to take this number out front into a number that's divisible here. And you want to kind of start from the left and work your way. Now, 21 is not going to be able to go into just 1 or 13. So I'm going to have to look at the 133. So if you don't know how many times 21 can go into 133, you can use a calculator or use some, longhand math over here and start taking 21 times 3 times 4 times 5 and see what number works. Now, when I did that, I found that 21 times 6 is equal to 126, and that's as close to 133 as I'm going to get. Then I'm going to subtract these, and I'm left with 7. What you need to do next then is bring down the 4 up here, because we haven't dealt anything with that yet, so we got to bring down that 4. So now we're trying to put 21 and divide it into 74. So again, if you need to, start thinking like, what's 21 times 2, 21 times 3? Well, 21 times a 3 is going to be 63. If you took 21 times 4, that would be 84, and that's going to be too big. So 3 is the most it can go in, and we do the same steps. We subtract again, and we got 11 here. Now, 21 can't go into 11. There's no more numbers for me to bring down in the long division because I've already brought down the 4, so I'm at the end of this number here. So this 11 would be known as the remainder. Okay, so there would be times that when you first learned about this, you would maybe have written it like this: 63, capital R for remainder, 11. Okay, but like I had said, this really brought us into the idea of fractions. So it can go in 63 whole times, and then that remainder means that there's like a portion that it can go in, but not completely because it doesn't go in perfectly. So to write it as a fraction, we would do 63, your remainder goes on top, 11, and then what you divided by goes on the bottom. So 63 and 11 over 21. Now we are going to be writing our answers like this when we start getting into dividing these polynomials. So you're going to see some that do go in perfectly and don't have a remainder, and then we'll see some that do have a remainder, and kind of how do you handle that, how do you write it. And so I'm going to show you how to do that by using fractions. So that's why I'm saying that we're going to have numbers or answers that look similar to what I just circled there in pink. So in order for you to divide a polynomial by a binomial, you want to first start by writing your equation out in long division form. So very similar to what we just did on that last problem, you're going to use your division bar and everything. And then you're going to kind of work through this piece by piece. You're going to try to take the first term of your binomial and figure out how many times it can go into that first term underneath your division bar. And then we'll do what we did, where we multiply and we kind of write down what we got when we multiplied, and we'll subtract. And we'll continue to bring terms down until we have nothing left to do. So for this first example here, we're taking x squared plus 4x minus 12, and we're dividing it by x minus 2. So I'm going to start by writing it out as a division problem. So the x minus 2 sits on the outside, and the x squared plus 4x minus 12 goes underneath the division bar there. Here's what you're going to start thinking of, and this is how you're going to do all of these problems. So the process is going to be the same every time. You're going to ask yourself, okay, I have an x out here, and I need to get it to become x squared. So what did I take times x to get to x squared? Well, back in chapter 7, when we were multiplying monomials and that, we learned that x times x would be x squared. So I'm going to put an x up here. So then what you're going to do is take that x and you're going to multiply. So think of like using your distributive property here. And you're going to do it 2 times because there's an x and a minus 2 out here. So we have x times x, which is x squared, and x times that negative 2, which would be negative 2x or minus 2x. Okay, when you guys do this step, these first two terms should always match. Like you should always have the same number and the same letter and the same exponent. So notice how I have x squareds. What I do next here is we subtract. Now when you subtract, these first two terms should always cancel. That's why I said they should always be the same, because you're going to want them to go away. Now be careful when you subtract the other pieces. Really watch for your negative signs that they're throwing in these problems. So this one we have 4x minus negative 2x. So if you need to think of it, it's really, this is what's going on right now. Think about your keep, change, change rule. Keep the first, change the next two. So it's actually adding those together, and we would have 6x. Then what you need to do is drop down the next term from your polynomial up here. So bring down that minus 12. And now what we're going to do is start over. Now you're thinking about, okay, this x here, how could I make that x become 6x? Well, if I take x times 6, then I would write it as 6x. So I'm going to write next plus 6. Okay, and then we're going to distribute. Once again, we're going to take 6 now, times that x, times that minus 2. So 6 times x would be 6x, and 6 times negative 2 would be negative 12 minus 12. Again, notice how the 6x's match. I said you guys wanted that to happen. So again, when I subtract, these are going to cancel. But if you look at the numbers, they're also the same, like negative 12 minus negative 12. So again, negative 12 minus negative 12, keep, change, change rule. You're adding opposites, you're going to get a 0. When you get a 0, that actually means that there's no remainder. So that means that x minus 2 divided perfectly into that polynomial that we started with. So my answer for this one would just be that x plus 6. There would not be a remainder for this one because we got that 0 down there at the bottom. So I want you guys to give this long division a try. So go ahead and pause the video here, try this problem out on your own, and then when you're ready to see the solution, keep watching. So I'm starting first by rewriting it as a long division problem here. So a, to get to a squared, we would have multiplied that by an a. And then you're distributing. So we got a squared minus 3a. And then we subtract. The a squares are gone. Now remember, there's a 1 in front of that a. So 1 minus negative 3. Again, we've got the double negatives happening there. So that really becomes an addition problem. So you have 4a, and then you need to bring down your minus 12. So then a, to get to that negative 12, or I'm sorry, to get to 4a, we take that times 4, so plus 4 up there, and then we distribute once more, and we have 4a minus 12. So again, I'm looking at this. If I go and I subtract, both of these are going to end up canceling because they're opposites of each other, and we get 0 for a remainder. So that a plus 4 is your answer, no remainder. So both of those problems, the one that we went through together, and then this one that you tried on your own, had no remainder. Like there was nothing added on to the end here. Now I want to show you a case where you will get a remainder, because I want to go over with you how do you handle that, how do you write on to the end of your problem that remainder that you found. So I'm going to start this the same way I started the last problems and rewrite it as a long division problem. So I'm going to put 4x plus 4 out front, and then we have 12x to the third plus 4x squared minus 4x minus 7. Now, the process of this is the exact same. So I'm not changing anything that we were just doing. We're going to do the same step by step thing that we had just been practicing there. So I'm at 4x, and I need to get to a 12x to the third. So 4 times 3 would get me to 12. I have x. I need x to the third. So I'm missing 2 of them, so I need to take it times 3x squared. Then again, we're going to distribute. So 4x times 3x squared should be 12x to the third. Again, I want to make sure that these match. And then 4 times 3x squared would be 12x squared. And that goes right underneath that 4x squared there. Now we're going to subtract. So those 12x to the thirds are gone. 4x squared minus 12x squared would be negative 8x squared, and then you need to bring down the next term. So bring down that minus 4x. So you can see all my steps there were the exact same as what we were doing up above. So now we're trying to go from 4x and get that to be a negative 8x squared. So 4 times a negative 2 would be your negative 8. And then I have x, I need x squared, so we're going to take it times x. Then again, you distribute, so negative 2x times that 4x would be negative 8x. Negative 2x times the 4 would be a negative 8x. And then we're going to subtract. Now be really careful here because you've got a lot of negative signs happening. So on the bottom here, you're really going to have negative 8 plus 8, which would be 0. So again, these cancel, which we want to see happen. And then again, you've got double negatives. So negative 4, keep change again. You're going to be left with a positive 4x, and then you want to bring down the next term from up above, which is that minus 7. So we're not quite done. We need to do this one more time. We're trying to get 4x to 4x. Now they already match. So if you can't multiply by a letter or a number to get them to be the same, remember, in order to keep a number the same with multiplication, you would be multiplying by 1. So I'm just multiplying by 1 here. And now I'm going to distribute once more. So we get 4x plus 4. And then we're going to subtract. Again, your 4x's are going to be gone, but we have negative 7 minus 4, which is negative 11. And you can see there's nothing left to bring down from my polynomial up here. So this is what I was talking about with the remainder. So how do you write the remainder in up here with this polynomial? So bring that purple polynomial that we wrote up here at the top, bring that out over here for your answer. So 3x squared minus 2x plus 1. That's all the stuff that went in perfectly, but then we have this remainder of a negative 11. So it's negative, which means that at the end of this, we're going to want to have a minus sign. So after that 1, you're going to want to do a minus sign because it's a negative number. And we're going to write it as a fraction. So on the top goes your remainder, which would be the 11. And on the bottom goes what you divided by. Just like when we did it with the 21 earlier, we put that remainder over what we had divided by, which was the 21. So you're going to put that 4x plus 4 on the bottom of this fraction here. And this is your answer. So that's how you're going to write it if there's a remainder that shows up. So practice on, no, don't practice on this one yet. We're going to go over this one together because this has a special thing happening. I want you to take a look at this polynomial here. We have 6x to the third plus 5x squared plus 9. Do you notice anything missing there? So hopefully some of you are seeing like, okay, we had x to the third, we had x squared. They skipped over a regular x and they went straight to 9. So when you see cases like that where they're skipping over a term, you have to put it in as like a 0 and then whatever letter, term, or piece of that polynomial that they skipped over. So let me show you what that looks like. You're going to bring down this 2x plus 3. You're going to start by doing your 6x to the third plus 5x squared. Now I said it had skipped over the x, so I need to put in a plus 0x to kind of hold that place. That still is the same thing as no x, because that would be a 0. But I need to hold the place so that when I go and do my division, I've got all the terms that I need, or else you're going to end up kind of having something kind of goofy happen when you're working through the problem. You're not going to be able to line everything up perfectly. So now what we're going to do is start thinking about our process, just like we did before. So 2x to get to 6x squared, you would have to take times a 3. and an x squared. Now you distribute. So 2x times 3x squared would be 6x to the third. And then 3x squared times 3 would be 9x squared. And now we subtract. So we have 5 minus 9, which would be negative 4, x squared, and you bring down the next term, which just happens to be that 0x. Now we start over again. So 2x going to negative 4x squared. 2 times negative 2 would be negative 4. I'm at x, I need an x squared, so I need to add on an x up there next to that negative 2. Distribute again. We would have negative 4x squared. And then negative 2x times 3 would be negative 6x. And again, this is why we put that 0x in there, because if I hadn't, this would be underneath my 9, and it really wouldn't make sense because I wouldn't be able to combine those because they're not like terms. So we have to have that 0x in there to hold its place. Okay, now we're going to subtract. So you have 0 minus a negative 6. You're going to end up adding that and get a positive 6 here. And then you bring down the last term, which is that 9. 2x to get to 6x, you have to multiply by 3. So you get 6x. And then 3 times 3 is 9. So again, this one, if you look, it's the same terms twice. So you're actually going to not have a remainder for this one. And so up here is your answer. Okay, so now what I want you guys to do is practice on your own here. So write it out as a long division problem. Check to see if you need to put in a 0 for any placeholders if it skips over any terms. Okay, so pause the video, try to do this problem, and then come back and keep watching to see how the solution should have turned out. So for this one, you did need to put in a 0x again because it does skip over that regular x term. So I'm just squeezing that in there. What you should have multiplied by first was a 3x squared to get your 12x to the third, and then it would be plus 12x squared. Then we subtract. 4 minus that 12 would be a negative 8x squared. And we bring down the second term, which is the 0x. We start over. So then you should have multiplied by a negative 2x to get negative 8x squared minus 8x. Again, we subtract. 0 minus a negative, you're going to end up adding, so you get positive 8x here. Bring down that minus 7. One last time, 4x to 8x would be a 2, so plus 2. And we would have 8x plus 8. You're going to have negative 7 minus 8, which would be negative 15. So this one did have a remainder. So up here on my answer, I'm going to do minus. 15 goes on the top of my fraction. And then what we divided by, which is that 4x plus 4 goes on the bottom. And this right here would have been your answer for that division problem.